So our last video in this chapter, we're wrapping up everything about electron configurations with finally figuring out what is the order that the orbitals are filled. It seems as though they start with the 1s and then the 2s and then the 3s and then the 4s. But as we saw in the last video, the 4s gets filled before the 3d. So there's something else going on. And what the rule that gives us the order for orbitals being filled is called the Aufbau principle. The Aufbau principle just basically says as the atomic number increases, the electrons are added to the orbitals with the lower energy first. So then what orbitals have the lower energy? So we're going to learn this two ways. One is with this particular diagram. So this particular diagram has little lines that stand for each of the orbitals, and you can see for every s orbital there's one line, and for the p orbitals there's 3, and for the d orbitals there's 5, f there's 7. You can see that the 1s is the lowest one, and the y-axis here is energy. So we're just going to follow the order that this diagram gives us. And we're going to do this with radon. Radon is number 86. It is going to be kind of long. So let's start at the bottom. Let's start filling up 86 electrons. Well, the first two would go in the 1s orbital. So in this box, I'm just writing the order of the orbitals. The next orbital that I fill are the 2s orbitals, and then the 2p, trying to get into the habit of always spreading them out before doubling them up. That's Hund's rule. After the 2p come the 3s. After 3s come the 3p. After 3p come the 4s. And you can see the 4s and the 3d are very similar, but if you actually look over, you can see 4s is lower. So now I fill the 3d, and 10 electrons can go in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After the 3d, I sort of have memorized that equals 30 electrons. So if I'm ever have to fill something that's very large, I know I can just go right to 3d. 3d is going to be 30 electrons. Now comes the 4p, and that's 1, 2, 3, 4, 5, 6. Now the 5s, so 5s, and now the 4d, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5p comes next. 1, 2, 3, 4, 5, 6. 6s, finally. We get to 6s, and this is really difficult to see, but look what happens if I zoom in. Can you see which one is lower? The 4f is actually much lower. I wouldn't say much lower, is actually lower than the 5d, so that gets filled first. So this is the first time we've ever gone to 4f. I'm going to have to go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. F orbitals can hold 14 electrons because there are 7 f orbitals. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And to get to 86, 1, 2, 3, 4, 5, 6. Ends in 6p6. So 6s, 4f, 5d, 6p. The full electron configuration. This is going to be kind of long. Write small. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10. 5p6, 6s2. And this is the one after 6s, 4f14, 5d10, 6p6. Shorthand configuration is going to be really handy here. The noble gas that comes before radon, radon's also a noble gas, but the noble gas that comes before radon is xenon. And then we would say 6s2, 4f14, 5d10, 6p6. So what is the order? Aufbau principle tells us that you start at the lowest energy and you go up. If you don't want to, who wants to memorize this, right? No one wants to memorize this. What is really interesting that you will notice is that this goes very well with the periodic table. Just to show you where radon is, this is where radon is on the periodic table, that one that we just did. And if I begin here, which is with hydrogen, and just read this like a book, literally from the left to the right, I would see that this is how I could get the order. I would go through 1s2, then 2s, then 2p, then 3s. See how I'm not going to 3d yet? Then 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and then this is where you need to remember. After 6s, you will go down to the 4f block. These F block elements are sometimes called the lanthanide and actinide series. The only reason why they really are stuck down bottom is otherwise the periodic table would be far too long and skinny. This makes it more like a normal sheet of paper size. And look at the numbers. If you look at the numbers, you can see that, you know, where we leave off after, I think it's barium, number 56, and then we go down to here. Okay, go all the way across 4F14, 5D10, 6P6. This is going to make it so much easier for us to do electron configurations. Okay, so let's do some electron configurations. Let's start with potassium. So now that I know this, now that I know I can use a periodic table, you know, find a periodic table. I'll give you one in class, and then you find the element. There's potassium. I can automatically, just by looking at where it is on the periodic table, I know it's going to end in 4s1. And what comes before it? Well, I started hydrogen, and I just read across. Okay, so here, I'll even maybe make this bigger so we can see it a little bit better. Right, so potassium, 1s2. Then I go down to the next row, 2s2 all the way across, 2p6. When I go through all of the blocks, that's each block is representing adding another electron, so the subscript gets bigger. After 2p6 comes 3s2, and then I'm all the way going over to argon, after 3s2, 3p6, and then potassium ends in 4s1, right? It's the first element in on that S block. Tantalum. Let's look at tantalum next. The hardest part of these is eventually going to be figuring out where these electrons or where these elements are. For some of the more obscure elements, usually where they are is either in the F block or the bottom part of the D block here. Tantalum is number 73. Tantalum is right here. So automatically, I know that this is going to be not 3D, 4D, but this is going to end in 5D. And since it's the third element over, I automatically know it's going to end in 5D3. Now I just start reading from the very beginning. 1s2, 2s2, 2p6, right? Start back at sodium, 3s2, 3p6, start back at potassium, 4s2, 3d10, 4p6. Now go back to rubidium, 5s2, 4d10, 5p6. Now we're at cesiums, 6s2. Now I need to remember, once I get to 6s2, whoop, I got to go all the way down to 4f14, all the way across here. Follow the numbers. Tantalum is number 73, so obviously I'm going to have to go through all the 60s and 71, 72 before I get to 73. After 4f14, that's when I pop back up, right? This guy is number 70. I pop back up to 71, 5d3. I'm going to let you guys do the next two on your own, and we'll check them in class tomorrow. The noble gas configurations. Noble gas configurations, we can do these the same way. I find arsenic on the periodic table. Okay, so I found arsenic on the periodic table. It is number 33. Look backwards. What is the noble gas that comes before it? The noble gas that comes before it is argon. So that's what goes in brackets, argon. And since argon is number 18, then I start reading at number 19 and read all the way over till I get to arsenic. So that would be argon, 4s2, all the way across 3d10, and then 4p3. Right? Zirconium. Zirconium is over here at number 40. What's the noble gas that comes before that? Krypton. And then you would go to 5s2 and then 4d2. Find the last two. I believe it's europium and astatine. Find those two, complete those noble gas configurations, and we'll check those in class the next day. And finally, our orbital diagrams. These are the ones with the arrows. You don't have the boxes to fill in here. You just need to draw the lines for the orbitals on their own. And make sure, for these, if I'll tell you exactly if I need noble gas configuration or full. Both of these are really long, so we'll do them with noble gas configuration. There's yttrium. So the noble gas that comes before it is krypton. So krypton in brackets, it has a krypton core. The next orbital is the 5s orbital, so I draw one line, a half arrow up and a half arrow down for the 2 electrons. Then the 4d orbitals comes next, and I draw all the lines. 4d, and even though for yttrium there's only one, I still need to see those empty lines there. Lead is a little bit longer. Lead is all the way down here, number 82. So we're definitely going to do noble gas configuration for this guy. He is xenon. After xenon comes 6s2, right? And one of the things I always say is in order to have 6s in chemistry, you need to remember you got to go down to the 4f orbital. So 1, 2, 3, 4, 5, 6, 7, 4f, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. After the 4f, you come back up to 5d. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we finally get to 6p, and lead is 6p2. So try these last two, dysprosium and iron, and we'll check them when we see you next.